Hi everyone, in this video we are going to talk about a solution stoichiometry. Now that we know how to express the concentration of different solutions using different units, then we will be able to perform stoichiometric calculations using common laboratory units of concentration. So in this lecture we are going to focus on the unit of molarity. Okay, so if you remember, molarity, two solutions can contain the same compounds but be quite different because of the proportions of those compounds, okay, being different as well. Okay, and then that means, for example, if you have a solution of H2SO4, then 6 molars of sulfuric acid is different from 12 molars of sulfuric acid. Okay, and one is more corrosive than the other because of the concentration of the H plus ions that comes from the acid. Okay, so as a review, molarity is the number of moles of solute per volume of the solution in liters. So that means we will have to get the number of moles of solute first if we have the given in grams. Okay, now we can actually use molarities in stoichiometric calculations. For for our review, we know very well that if we are given the amount of substance in grams, okay, or amount of substance A in grams, then we can actually calculate the amount of substance B in grams as well. And we have to go through this process. So again, we use the molar mass of A to convert it into moles of A, and we use the stoichiometric coefficients that are found in a balanced chemical equation to convert moles of A into moles of B. After that one, if we want to get the grams of B, then we'll have to use the molar mass of B. All right, but where do we insert molarity? Take note that when we are given the volume or the molarity of substance A, we can convert it into moles. Okay, we can get the number of moles of substance A if we have both the volume and the molarity. Okay, after that one, we can go to the same process again and end up with the volume or the molarity of substance B. All right, let's try to use this in an example. Okay, so here I have a problem wherein 50 ml of 6 molars of sulfuric acid, which is also commonly known as battery acid, it was spilled. Okay, were spilled, and solid sodium bicarbonate is needed. Okay, and that's baking soda is needed to neutralize the acid. So how many grams of sodium bicarbonate must be used? So our situation calls for a balanced chemical equation. So this is a neutralization reaction wherein a strong acid is being neutralized by a strong base. And the usual products are water molecules, and a certain salt. Sometimes a gas may evolve. All right, but here is our balance equation for this problem. And please take note that our substances of interest are the baking soda, which is sodium bicarbonate, NaHCO3, and sulfuric acid, H2SO4. Okay, and what we do have in our given is the volume of sulfuric acid, which is 50 ml. Okay, 50 ml, and the molarity or the concentration of sulfuric acid, which is 6.0. Now take note that 6.0 molars can be written as 6.0 moles per liter solution. So 6.0 moles sulfuric acid per liter solution. Now, what we can do here is always remember that if we have this, if we have the volume and the concentration of a substance or a solution, we can actually get the number of moles. All right, using this relationship. So 50 ml, all we need to do is just convert liters to ml, so that we will end up with the number of moles of sulfuric acid. But going back to this problem, we are asked for how many grams of sodium bicarbonate there are, right? So what can we do? So in getting the number of grams of sodium carbonate, okay, we have to form our working equation first. We start with our given, so we know very well that we have 50 ml of sulfuric acid, and we also have the molarity. Take note that the molarity of sulfuric acid can be used as a conversion factor so that we will end up with the number of moles. All right, so all we need to do is convert liters to ml. And we remember that 1 liter is equal to 1000 ml, okay, 1000 mil. Now we take a look at how we can cancel mils of H2SO4, okay, and we end up with moles of H2SO4. Okay, now that we have our moles of substance A, we can now get the number of moles of sodium bicarbonate. So this is where the mole ratio is needed. Okay, if you remember, in converting moles of substance A, as in this case it is sulfuric acid, and into the moles of substance B, which is NaHCO3, we need to get the mole ratio from the balance equation. Okay, so our balance equation tells us that for every 1 mole of sulfuric acid, we need 2 moles, this one, 2 moles of sodium bicarbonate. Okay, we need to place sulfuric acid down below so that we can cancel, and then on top is the number of moles of sodium bicarbonate. Notice how we can cancel out moles of H2SO4 and end up with moles of NaHCO3. All right. And then after that one, since we are asked for the grams of NaHCO3, sodium bicarbonate, we can now use the molar mass of sodium bicarbonate, which is 84.02 grams per mole. Right? If you try to look at your periodic table, you can get the molar mass of NaHCO3. So 1 times the atomic mass of sodium plus 1 times the atomic mass of hydrogen, carbon, and then 3 times the atomic mass of oxygen. So we all in all, we end up with the molar mass of the compound, which is 84.02 grams. Now we can cancel moles of NaHCO3, and we end up with the unit of grams. Grams NaHCO3, or sodium bicarbonate. So in our calculators, we can do the operation. So that's 50 times 6 divided by 1000 times 2 divided by 1, or you may not do it. Okay, so times 2 times 84.02. So we will have an answer of 50.4 grams of sodium bicarbonate. Okay, so you need this mass of sodium bicarbonate to neutralize the acid. So let's try out this next example. This time, let us calculate the volume. So determine how many ml of 0.102 molars of sodium hydroxide solution are needed to neutralize 35.0 ml of 0.125 molars of sulfuric acid solution. All right. So if you've noticed, in one of our given, we have the volume and the concentration in molarity. Okay, and we are asked for the number of or for the volume of sodium hydroxide. Okay, so first we need to have a balance equation. Okay, and then just very quickly, we know that 2 moles of sodium hydroxide react with 1 mole of sulfuric acid to form 2 moles of water and 1 mole of sodium sulfate. And after that one, we can now look for our given. We know that we have 0.102 molars of sodium hydroxide, okay, which we can rename as moles per liter, okay, so that our units will be consistent later on. Okay, and then we also have 35.0 ml of sulfuric acid. Okay, so and the concentration of sulfuric acid is 0.125 molars. Okay, and molars can be written as moles per liter. However, let us convert liter in mil right away. Okay, because anyway, we are looking for how many ml of sodium hydroxide solution there is. Okay, so again, 1000 ml is equal to 1 liter. Now we are looking for the ml of sodium hydroxide. We want this volume for sodium hydroxide. So how do we do it? In order to get the mil of NaOH, okay, we start with our given. So you notice that the pair is here, the volume and the concentration. So what we can do is start our equation from there. So we can multiply the volume of sulfuric acid by its molarity, by its concentration. So we have 0.125 moles over 1000. This is obtained from the given 0.125 molars of H2SO4. Notice how we can cancel mil of H2SO4. All right. So we cancel mil of H2SO4 and we end up with the number of moles of sulfuric acid. Okay. Now that we have the number of moles of sulfuric acid, we can use the mole ratio. Okay, so again, moles of A, to convert it into moles of B, we use the mole ratio, which is given in the balanced chemical equation. So we know that 2 moles of NaOH reacts with 1 mole of H2SO4. And then we can cancel moles of H2SO4. After getting the moles of NaOH, we can now get the volume, the total volume of NaOH that will be reacting in the solution with the sulfuric acid solution. So we can cancel moles of NaOH to get mil NaOH. Okay, and where did we get this value? We obtained it from this, from our given. Take note that we have 0.102 molars of sodium hydroxide. Molar is equivalent to mole per liter. Okay, so this is equivalent to 1 liter, the 1000 ml. Now we can cancel moles of NaOH. Okay, so again, this conversion factor here comes from our 0.102 molars NaOH. It's just that we use 1000 ml instead of liters. Okay, now that we are ending up with the unit that we want, which is mil of NaOH, then we can carry out our calculation. So you may pause this video to reflect on where did the conversion factors come from, or carry out your calculations. Okay, so that means you have 35 times 0.125 divided by 1000 times 2 times 1000 divided by 0.102. You end up with 85.8 ml of NaOH. Okay, so you may pause this video if you have questions or you need to revisit something. Now, this is our last example, example number 3, using mass relations in a neutralization reaction. So we got this from Brown textbook, and then it asks for how many grams of calcium hydroxide are needed to neutralize 25 ml of 0.100 molars of HNO3. All right. So if we are going to analyze, so we have here a step-by-step procedure also obtained from the textbook, and you may refer to this if you are that kind of learner. Basically, what it's saying here is that we can multiply the volume of HNO3 with its molarity so that we can get the number of moles of HNO3. Okay, let us just be consistent with our units. And then after getting the moles of HNO3, we can get the number of moles of calcium hydroxide, and after that, get the amount in grams. Okay, so in the first step, we are saying here we converted 25.0 mil into liters. So that is basically just moving the decimal point 3 times to the left. So you have 0.0250 liters and then multiply it with the concentration, molarity, so moles per liter. And we end up with 2.50 times 10 to the negative 3 moles of HNO3. Before that, we need to have also the balanced chemical equation so that we will be able to get the mole ratio. All right. So in getting the mole ratio, we refer to the balanced chemical equation here. So we have 2HNO3 plus calcium hydroxide will give us 2 molecules or 2 moles of water and calcium nitrate. And we see that 2 moles of HNO3 is stoichiometrically equivalent to 1 mole of calcium hydroxide. And therefore, we can now use the number of moles that we have from a while ago of HNO3, and we use the mole ratio, which is 1 mole of calcium hydroxide is to 2 moles of HNO3. And after that one, since we want to have the grams of calcium hydroxide, we use the molar mass of calcium hydroxide as our conversion factor. So remember that in getting the molar mass, you have to refer to your periodic table and then add up the atomic masses and make sure that you follow also the subscripts. So all in all, we have 74.1 grams of calcium hydroxide. And therefore, if you carry out the working solution, you have 2.50 times 10 to the negative 3 divided by 2 times 74.1 grams is equal to 0.0926 grams of calcium hydroxide. Okay? So you may pause this slide or this page and then reflect and then try to check and reflect on your solutions. Now it's your turn, okay? I have here two check-up questions, which I'd like you to answer on your own without me discussing, and the answers will just be given. For the first question, we have how many grams of NaOH are needed to neutralize 20 ml of 0.150 molar sulfuric acid. So this means that you will have to generate or to build up your balance equation on your own. Okay, so this is a skill which you must have learned in the previous sessions. The next question is how many liters of 0.5 molars of hydrochloric acid are needed to react completely with 0.10 moles of lead nitrate, forming a precipitate of lead chloride, lead 2 chloride. Okay, so you also need to build up or generate the balanced chemical equation for this. So you may start solving now. So the answer for question A is 0.240 grams of sodium hydroxide, while for question B, it should be 0.400 liters of HCl. Okay, if you got these answers, congratulations, you're doing a great job. If not yet, so don't worry, you're on the way, and yeah, you can revisit your answer, reflect on what might have gone wrong, and then try to work it out again. Okay? So this ends this lecture video on solution stoichiometry. Have a good day, and I hope that you enjoy the rest of the day.